Hello, let us talk about our environment. Did you know that the ocean generates 50% of the oxygen we need? It absorbs 25% of all carbon dioxide emissions and captures 90% of the excess heat generated by these emissions. It is not just the lungs of the planet, but also it's the largest carbon sink, which is a vital buffer against the impacts of climate change. Even under the most optimistic decarbonization scenarios, the world will need to remove tens of billions of tons of carbon dioxide from Earth's atmosphere in the coming decades to stay under 2 degrees Celsius of warming, key threshold beyond which climate impacts become more severe and irreversible. While there are many proposed strategies to remove carbon dioxide from the atmosphere, one of the most promising approaches seeks to leverage the natural attributes of the ocean. To save the planet, some scientists came up with marine carbon dioxide removal strategies. It is a set of methods and techniques that capture and store carbon dioxide from the ocean or atmosphere. Because atmospheric carbon dioxide concentrations are at dangerous levels and security continues to emit huge quantities of CO2. Scientists are examining different ways to pull it from the air. The world's oceans naturally absorb about 25% of human CO2 emissions. Altering the sea's biology or chemistry would stimulate it to soak up more. When the partial pressure of CO2 in the ocean is lower than it is in the atmosphere, more CO2 from the air dissolves into the water. So, by this concept, various methods are devised. These methods are biological methods, chemical methods. Biological methods consist of microalgae fertilization, macroalgae cultivation, blue carbon restoration, and the chemical methods consists of direct ocean removal, ocean alkalinity enhancement. What is macroalgae cultivation? As the marine plants grow, they store carbon in their tissues. Cultivating macroalgae such as seaweed could draw more CO2 from the ocean, allowing it to extract more from the air. Microalgae fertilization. Phytoplankton take in sunlight, CO2, and nutrients to grow, fertilizing surface water with nutrients such as iron that can enhance the growth and therefore the CO2 consumption. As phytoplanktons die, they sink to the seafloor, sequestering the carbon there. Let us understand artificial upwelling. Instead of fertilizing the surface water, there are pumps which can bring nutrients there from deep water, stimulating algae growth and CO2 absorption. Chemical methods. Direct ocean removal. Pumps can bring seawater into an onshore or a floating facility that extracts CO2 and stores it. The deficient water is sent back to the ocean where it can absorb more airborne CO2. The 37 billion metric tons of CO2 we emit every year constitutes a tiny percentage of Earth's voluminous atmosphere, yet it has an outsized impact on our climate. Not emitting the gas in the first place is a far simpler, cheaper, and more reliable solution than finding a technology to pull this trace gas out of the atmosphere. But even if we could halve the emissions within the coming decade and slash emissions by 90% just 20 years later, we will still face roughly 50-50 odds of overshooting 1.5 degrees Celsius of global warming. The researchers are now researching MCDR, so the strategies might someday help the society to solve the final few percent of the problems.